Tonight, new orbital data has quietly surfaced. A second object has entered the inner solar system, accelerating along a path that almost mirrors 3i Atlas. Its trajectory is not random. It's angled in, timed, and set to reach perihelion at nearly the same moment. The timing isn't measured in months or weeks, but in days. We've been following 3i Atlas for weeks. We know its inbound velocity, its strange maneuver window, its October 29th perihelion. Now, something else is racing toward the same solar corridor. Observatories aren't issuing public alerts, but the orbital fit models are already circulating among specialists, and the match is too close to ignore. The story begins with a trajectory. 2 objects, 1 path, 1 window. And from here, the pattern only gets stranger. The new object was first logged in the public registry less than 48 hours ago. The initial detection came from a deep field sweep conducted at the edge of the twilight zone, a region where inbound objects are often found late because they approach from the sun's glare. Its signal was faint but clean, a fast-moving object with an angle of approach that immediately raised eyebrows in tracking centres. When analysts overlaid its orbital arc with the path of 3i Atlas, the resemblance was unmistakable. 2 curves, one chasing the other, bending toward the same corridor of space. This is not a common scenario. Most inbound objects approach from wide, scattered angles, arriving months or years apart. Their perihelia, the points of closest approach to the Sun, usually fall on entirely different dates. But here the first solutions show something different. Both objects are set to pass through the same sector of solar space in late October, just days apart. One, 3i Atlas, has been under tight international observation for months. The other emerged in silence, detected only because its signal crossed a narrow field of view at the right time. What stands out most is the timing. If these were random, long-period comets or interstellar visitors, the statistical probability of 2 aligning so precisely in both trajectory and schedule would be exceptionally low. Objects like these drift through space independently, shaped by gravitational slings, perturbations, and chaotic interactions over eons. For 2 of them to arrive almost in tandem raises 2 possibilities. Either this is an extraordinary coincidence, or there's a deeper pattern at play. Specialists are already dissecting the orbital elements: inclination, perihelion distance, eccentricity. The inclination is nearly matched. The eccentricity ratios are unusually tight. And the perihelion passage, aligned to within a single week. That's not something often seen in natural inbound traffic. Some analysts are already calling it a twin trajectory, but it's the velocity profile that complicates things further. The new object is accelerating slightly faster than 3i Atlas at this stage, closing the solar distance at an unusually steep gradient. That suggests one of 2 things. Either it's smaller and being more strongly affected by solar gravity, or there's something about its composition or behaviour that isn't ordinary. If it maintains this pace, it may overtake or flank 3i Atlas at the perihelion window. Behind the scenes, tracking centres are linking the data streams. Observatories from different hemispheres are quietly syncing their models to refine the approach. No press releases have been issued yet, but the modelling chatter is escalating. Because what begins as trajectory alignment often leads to deeper questions. Was this inbound path set in motion ages ago? Or is something more recent shaping these vectors? The first set of velocity readings came in less than a day after the object's initial detection. At that point, analysts assumed the acceleration profile would follow a familiar pattern, a natural fall inward, gradually steepening as it approaches the Sun. But within hours, the numbers began to deviate from that curve. It wasn't dramatic at first, a small but measurable divergence, a steady, controlled climb in velocity where there should have been a smooth gravitational slope. In tracking rooms, those kinds of deviations are watched closely. When they persist, they stop being noise. They become data. To put this into perspective, inbound objects typically accelerate predictably as they fall deeper into the Sun's gravity well. Every kilometre of distance inward corresponds to a calculable increase in velocity. The new object is not just accelerating faster, it's doing so with almost surgical precision, as if it were pacing itself. A steady escalation that matches, then slightly surpasses, the inbound speed of 3i Atlas. The result is what analysts call a velocity shadow, a trailing object sinking itself with a lead target. This is rare in nature, but common in controlled pursuits. The strange part isn't just the acceleration itself, it's how consistent it is. Natural forces are messy. Dust, gas jets, rotational tumbling, all of these cause tiny fluctuations that show up in readings as noise. But the curve of this object is clean. No visible outgassing, no sudden jumps or dips, just a smooth, rising line that seems to follow a hidden schedule. Ground-based observatories weren't the only ones to notice. A deep space monitoring array used to track near-Sun activity flagged the same pattern in its telemetry. Within hours, several high-level observation channels began coordinating their measurements, refining the readings, trying to find any sign of natural explanation. So far, none fits perfectly. The most conservative voices argue for an icy nucleus with well-shielded jets, producing thrust invisible at current resolution. Others quietly suggest something harder to explain: intentional pacing. And here's where the timeline matters. 3I Atlas is inbound on a schedule that culminates on October 29th, the date of perihelion. This second object is closing in, but slightly ahead of the modelled expectation. If it maintains its current acceleration, it will reach the perihelion window just hours, maybe a day or two, before 3I Atlas itself. That would put the two objects inside the same sector of solar space at nearly the same time, and in orbital mechanics, timing like that isn't trivial. It's deliberate, or it's extraordinary. There's also an atmospheric factor in play. As objects approach the Sun, they typically become harder to track due to intense glare and solar wind interference. During this period, known among observers as the silent zone, objects can slip beneath direct observation. A synchronized acceleration leading into that zone means that for a critical window, possibly several days, both 3I Atlas and this second object could be invisible to ground-based optical tracking. That's not just inconvenient. It's a blackout that happens to line up perfectly with their convergence. Inside specialist forums and closed observation groups, conversations have shifted tone. Early on it was curiosity, now it's strategy. Teams are recalibrating their instruments to keep a lock on the object as it dives toward the blackout. High-altitude observatories and solar coronagraph arrays are being prepped for longer observation runs. The quiet urgency isn't public, yet, but it's unmistakable in the data community. And then there's a subtler layer. 3I Atlas has been tracked for months, its trajectory refined down to tiny tolerances. But this new object has appeared late, so late that its inbound speed suggests it may have already been within the inner solar system for some time, hidden behind glare or too faint to resolve. That late detection, combined with the clean acceleration curve, raises uncomfortable questions. Was it just missed? Or was it always there, waiting? Either way, this isn't a drifting rock anymore. It's an object moving with purpose, or at least with extraordinary precision. The acceleration spike isn't just a data point. It's a signal, one that's pulling both objects toward a shared moment near the Sun, and as the velocity shadow grows tighter, the countdown accelerates with it. By the time an object reaches the inner edge of the solar observation corridor, timing stops being a background detail. It becomes the story. That's where both 3I Atlas and the newly detected object are heading, fast. In the language of orbital mechanics, a perihelion window isn't just a point in space. It's a thin slice of time where trajectories compress, shadows lengthen, and the Sun's glare dominates everything. For most comets or interstellar bodies, these moments pass quietly, unnoticed by anyone but a few astronomers and data analysts. But this isn't most objects. This is two trajectories converging so tightly in both space and time that they appear bound together by something more than chance. The first models that charted this convergence looked almost too clean. Lines on a heliocentric graph, two arcs bending toward the same solar corridor, intersecting within days of each other. The probability of that alignment happening at random is low. Not impossible, but rare enough to draw immediate attention from multiple independent observatories. It's the kind of alignment that forces everyone to recheck their data, to look for software errors, miscalculations, anything that might explain away the precision. But after repeated verification, the convergence stood firm. Both objects are approaching perihelion between October 27th and October 31st, with 3I Atlas peaking at October 29th. The second object, if the acceleration spike holds, may slip in just before it. This is where orbital timelines get unnervingly tight. In deep space, a difference of a few days is negligible. Near the Sun, a few days can mean overlapping thermal envelopes, overlapping plasma wakes, overlapping blackout periods. If the trajectories remain as they are, there will be a stretch of time when both objects will vanish behind the solar glare, effectively unobservable from Earth. During that blackout, the only instruments capable of keeping watch will be solar coronagraphs and space-based observatories, and those too have limits. Here's why this matters. When objects enter this solar silence zone, communication and observation networks thin out dramatically. The Sun floods detectors with noise. Instruments meant to filter out that noise are already pushed to their limit by the presence of 3I Atlas alone. Adding a second, faster-moving body to the same window doesn't just double the challenge, it compounds it. If anything unexpected happens, a sudden break, a change in course, an energy release, it could happen entirely out of view. And here's where analysts begin to disagree. Some see this as pure coincidence. Two long-period objects, both nudged inward by gravitational interactions over decades, finally arriving at a similar window. Space is vast, but it has its corridors. Gravitational highways exist, and objects sometimes ride them in clusters. It's not unprecedented. But others, especially those who have been tracking 3I Atlas closely, aren't so quick to accept coincidence. They point out that both objects are not just on similar inbound vectors, they are timed. The second object's acceleration began aligning perfectly to bring it into phase with 3I Atlas's perihelion. If it was drifting freely, the odds of it pacing itself this precisely are slim. The maneuver window is what everyone's quietly watching. For 3I Atlas, late October is the point where its behaviour could shift. Its velocity curve, its light signature, and its predicted coma development all suggest something could change as it nears the Sun. If the second object is acting as a precursor or trailing partner, the perihelion moment might reveal the connection. Some have suggested it could be a fragment, a detached mass ejected earlier that has maintained a stable but separate orbit. Others are less convinced. The clean acceleration curve, the late detection, and the near-perfect temporal alignment all suggest something less accidental. Adding to the tension is the duration of the silence. Normally, when an object vanishes behind the Sun, the gap between the last visual tracking and the first reappearance is only a few days, but 3I Atlas is massive. Its blackout is expected to last longer than average, potentially up to a week. The second object, with its steeper velocity profile, could slip into and out of that blackout at a slightly different angle. That means there will be a window of overlapping silence where neither object is visible, neither is trackable, and the only thing left is a data gap. For astronomers, data gaps are like blindfolds. For intelligence networks, they're choke points, moments where the unknown has room to breathe. If anything is going to happen, if anything is going to change, that's when it will. Observers are already preparing for this moment. Solar coronagraphs positioned around the Sun, particularly instruments on space probes and orbital platforms, are being recalibrated to extend their coverage. Some observatories are planning overlapping exposure runs, hoping to catch brief flashes or indirect signatures, even as the glare consumes the primary signal. It's a race between time and light. Once both objects are in that corridor, the Sun becomes a wall, and then there's the psychological weight of the date itself. October 29th isn't just a random point on the calendar anymore. It's become a marker, a line toward which both trajectories are inexorably bending. The closer they get, the less room remains for error or coincidence. And behind the scenes, every shift in trajectory, every fractional increase in acceleration is being monitored with quiet intensity. This isn't just about position anymore, it's about synchronization. In orbital dynamics, synchronized arrivals aren't a common sight. When they occur, they either belong to structured systems, like debris fields following a parent object, or they suggest a more complex dynamic at play. A single interstellar object is a mystery. Two, arriving in sequence converging on the same solar window becomes a pattern. There's also a hidden layer to this convergence, the gravitational environment around the Sun at perihelion. The solar wind, magnetic field interactions, and coronal mass ejections can all act unpredictably during these windows. Two bodies in close temporal proximity could influence each other subtly, gravitationally, magnetically, or through material interaction if their comas overlap. Even if both are purely natural, their near-synchronous arrival could produce complex effects, making the perihelion data far messier than analysts would like. But what makes this convergence so unsettling is not just the physics, it's the silence surrounding it. No official agency has issued a statement acknowledging the second object's synchronized timeline. The data is there, circulating quietly through observatory networks and specialized trackers, but the absence of public communication stands in contrast to the scale of the anomaly. When something of this magnitude happens in space and the silence persists, observers know they're standing in the shadow of something bigger. The countdown to convergence has already begun. Each passing day narrows the maneuver window. The acceleration of the second object is holding steady. 3i Atlas continues its descent. Both curves are now moving like twin threads toward a single knot in time. And the strange truth is this: once they enter the solar silence zone, we will lose sight of both. We'll be watching the sun, not the objects, waiting for what re-emerges or what doesn't. When objects are first tracked inbound toward the sun, mass is one of the earliest estimates attempted, not through direct measurement, but through how they behave. Light curves, acceleration profiles, sublimation rates, and gravitational interactions paint an indirect picture. For most comets, the estimates eventually settle into a stable range that aligns with what telescopes observe. But here, with these two objects, the mass signals are behaving in opposite and conflicting ways. 3. Atlas has long been the outlier. Since its first detection, its mass signature has been unusually high compared to its apparent size and reflectivity. Analysts initially suspected a dense core or an internal structure unlike standard icy bodies. Over the months, this suspicion has only grown. Its gravitational influence on surrounding dust and small fragments was measured multiple times, producing results more in line with a large metallic asteroid than a typical interstellar visitor. That alone would have been enough to keep 3i Atlas at the centre of global attention. But the arrival of this second object has complicated the picture. Its velocity profile implies a lower mass, something small, nimble, responsive to solar pressure, yet its optical signature tells a different story. The light curve suggests an object with a significant surface area. It reflects like something larger. In simpler terms, it's moving like a feather but shining like a boulder. That contradiction is what has data teams working through the night. Several models have been proposed to explain this. One suggests the second object could be hollow or porous, a structure with a large reflective surface but very little internal weight. That would account for its responsiveness to solar gravity and radiation pressure. But that explanation only goes so far. For the acceleration spike to match what has been recorded, the object would need to have an unusually stable orientation in flight. Natural tumbling, common in fragments and comets, would produce chaotic accelerations, but here the curve is smooth, continuous. It's almost as if the object is holding its orientation deliberately. There's another model, one that analysts are reluctant to say publicly. If the object isn't naturally shaped, if it has surfaces aligned intentionally, it could be steering itself through passive means using sunlight like a sail. It wouldn't need propulsion to adjust its trajectory. Its structure alone could make it responsive. If that were true, the mass estimate would no longer be an accident of physics, it would be design. But even if we step back from speculation, the ratio between the two objects is telling. 3i Atlas has an inertia that resists solar pull, an inbound path that remains stable despite the turbulence of the heliosphere. The second object seems to dance through that turbulence, matching 3i Atlas's timeline without matching its bulk. The result is what's being called an asymmetric pair, one heavy, one light, both inbound on the same corridor. This kind of pairing is rare in natural systems. Asteroids with companions tend to orbit each other, or travel as debris clusters that are visibly related. Here, there's no visible tether, no surrounding debris field connecting them. They are separate bodies, arriving on separate but synchronized arcs. That raises the question of whether the second object is a follower, a trailing body reacting to the gravitational well of 3i Atlas, or whether it was always meant to arrive in its wake. Another point drawing attention is the light decay profile. As an object nears the sun, its light curve usually brightens rapidly due to sublimation, ice turning to gas, creating a coma and tail that reflects sunlight intensely. 3i Atlas has been brightening predictably, its coma expanding in line with expectations. The second object, however, is not following this pattern. It remains bright, steady, and controlled. There's no broadening of its signature, no diffuse tail flaring outward. Its brightness behaves more like a fixed surface than an evaporating mass. This behaviour suggests something with unusual thermal properties. If it's composed of material resistant to rapid sublimation, or if it has a structure that prevents the typical flare-up, that would help explain the mass discrepancy. But it would also make it unlike most inbound objects ever catalogued. Natural or not, its material signature doesn't fit neatly into the databases. Behind closed doors, mission planners and data analysts are running quiet simulations. If the second object is indeed far lighter, it would be more vulnerable to changes near perihelion, sudden acceleration, solar wind, or magnetic interactions. That means if anything unexpected happens around October 29th, it may be the first to react, shifting course or revealing more of its nature. 3i Atlas, with its heavier mass and stable profile, will likely punch through whatever happens. The smaller object, however, may be the first to break pattern, and this leads to an unsettling possibility. If both objects are part of the same event, whether natural or not, the mass discrepancy could indicate different roles. One anchor, one shadow, one built to endure, one built to follow. Patterns like this don't emerge often in celestial mechanics without cause. Some have pointed out an even stranger detail. The distance between their projected perihelion points is shrinking over time. As the second object accelerates, its approach vector is bending slightly inward, narrowing the gap. It's subtle, almost invisible on wide-scale charts, but on precision plots it's measurable. If this continues, both objects could reach their perihelion at nearly the same heliographic longitude, only separated by a few solar hours. That's not typical, that's choreography. No official statement has acknowledged this mass discrepancy yet. The orbital bulletins remain technical, dry, and incomplete. But in specialized tracking rooms, the unease is growing. Because mass defines how objects behave in the sun's grip, and when two objects defy those expectations together, something deeper is usually at play, and as the calendar edges closer to late October, the patterns aren't simplifying, they're tightening. Every inbound object, no matter how bright or large, eventually crosses a threshold where observation becomes nearly impossible. As they approach perihelion, the sun's glare becomes overwhelming. Telescopes on Earth are blinded, ground-based tracking falters. Even high-altitude observatories struggle to pick out faint signals against the relentless blaze. This is what astronomers call the solar blackout window, and both 3i Atlas and the newly detected object are set to vanish into it almost simultaneously. The timing is precise. According to updated tracking data, 3i Atlas will pass behind the Sun from Earth's perspective in the final days of October. The second object, following its steep acceleration profile, will enter the same region only hours earlier. For a period that could last from 5 to 8 days, both objects will be completely hidden from direct optical observation. It won't be a partial dimming, it will be a total blackout. This silent zone is not a mystery in itself. It happens with comets and asteroids every year. But what's different here is the overlap. Usually, even when two inbound bodies share the same season, their blackout windows don't align. Their timing is offset, their orbits diverge. But here, the alignment is exact. One heavy, stable body, one light, accelerating shadow, both disappearing together behind the same solar curtain. What happens during that blackout will not be visible to anyone on the ground. Solar coronagraphs aboard satellites, instruments designed to block out the sun's light and observe what happens around it, will be the only eyes left. And even then, their coverage has blind spots. Instruments like these are built to monitor coronal mass ejections, not track two synchronized interstellar objects. Their ability to provide continuous high-resolution tracking is limited, which means that for several critical days humanity will be essentially blind. The silent zone isn't just a physical barrier, it's an informational vacuum. In the past, similar blackout periods have led to moments of speculation, confusion and rumour. When C/2012 S1, Ison, approached the Sun in 2013, a wave of false reports spread in those few hours when no one could confirm whether the comet had survived perihelion. In the vacuum of data, stories grow. This time, the stakes are higher. 3i Atlas has already drawn worldwide attention, and now a second inbound object has entered the equation. When they vanish, the world will be forced to wait. Teams working behind the scenes understand this better than anyone. They're already drawing up contingency plans, synchronized observation schedules, data sharing protocols between agencies, even informal agreements to release fragments of telemetry in real time. But even with preparation, there are limits. Solar glare is not a challenge that can be solved with coordination. It's a wall. What concerns many isn't just what will be unseen, it's how long it will stay that way. Because blackout periods aren't fixed. If solar activity spikes, if a flare or coronal mass ejection occurs during that time, it can lengthen the silence. Dust and plasma from the sun can scatter signals, distort readings, or hide an object's light curve entirely. In the most extreme cases, redetection after perihelion can be delayed for days, even weeks. If that happens this time, both objects could slip through a window of total obscurity. There's also the matter of what can change during that silence. Trajectories near the sun aren't static. Solar wind, radiation pressure, and gravitational perturbations can shift orbital vectors subtly or dramatically. If either object undergoes fragmentation, acceleration, or any kind of maneuver, those events would unfold without anyone watching. We'd only see the aftermath, a new trajectory, a brighter coma, or perhaps nothing at all. Some analysts are already talking about a drift scenario. In this scenario, the second object, lighter, more sensitive to solar forces, could alter its velocity profile during blackout. It could slow, accelerate, or shift position relative to 3i Atlas. When the objects re-emerge, their spacing could be different. In a natural case, this would be expected. But if the objects are acting in some coordinated fashion, the blackout provides the perfect cover. A maneuver here wouldn't have to fight public scrutiny. It would happen in silence. The silent zone also brings a different kind of tension, psychological. When a story has built for months, as 3i Atlas has, the moment it disappears becomes the moment of maximum speculation. It's the point where imagination fills the gaps. If anything unusual happens during that invisible stretch of sky, we won't know until it's already done. And for a growing number of analysts, that uncertainty is the real anomaly. It's not just the synchronized timing of their blackout, it's the opportunity that blackout creates. Even outside the astrophysics community, this approaching silence has caught the attention of defense networks and orbital surveillance agencies. The International Asteroid Warning Network, which has already been issuing formal observation calls on 3i Atlas, is reportedly running parallel tracking models for the second object, though no public statement has been made. For them, the blackout isn't just an observational gap, it's a period where verification collapses. In the event of sudden changes, detection would lag behind reality. And then there's the radio wave factor. When optical visibility is lost, some turn to low-frequency radio observations or indirect signal monitoring. In some past events, faint emissions or scattering effects have been detected even during blackout. Some arrays are being retasked quietly to monitor the perihelion corridor, not for images, but for anything unusual in the electromagnetic spectrum. Even a tiny irregularity in those readings could signal an event unfolding behind the sun, but the truth is simple and unavoidable. For several days around late October, both objects will cross into a space where no one can watch them directly. No telescope on Earth will pierce that veil. No agency can guarantee real-time updates. The trajectory plots will pause, waiting for reappearance data, and this is why the silent zone matters, because everything leading up to this moment, the twin trajectories, the acceleration spike, the synchronized timeline, the mass discrepancy, will culminate in a single invisible interval, a moment in time when two unknown objects converge beyond the reach of our eyes. Somewhere behind the solar curtain, their paths will cross. Whether nothing happens or everything does, no one will see it. Only after they emerge will the story resume. Long before 3i Atlas drew global focus, long before the second object's arrival tightened the clock, there were other inbound bodies whose timing raised quiet questions in the astronomical community. These moments never made headlines. They were footnotes, anomalies folded into larger datasets, logged and left behind. But in the past few weeks, archivists and orbital analysts have been digging through those records, and what they're finding is unsettling. Patterns emerge slowly in astronomy. A single alignment means nothing. Two suggest coincidence, but when the same kind of alignment begins to appear across different years, different inbound objects, and different orbital angles, coincidence starts to look less like the answer. According to internal reports now circulating among observatory networks, this isn't the first twin window arrival, the simultaneous convergence of two objects on nearly the same solar corridor. It's the fourth documented case in less than 3 decades. The first happened in the late 1990s. 2 small faint objects, both classified as sun grazers, were detected inbound on almost parallel trajectories, separated by less than 4 days at perihelion. At the time, technology was more limited. Solar coronagraphs caught partial signatures, but one of the objects vanished completely after its solar pass, leaving behind no debris. The event was dismissed as a breakup, a fragment lost to the Sun. The second occurred in the early 2000s, with a pair of inbound comets arriving in near synchrony. Both were smaller than 3I Atlas, but exhibited a similar pattern. One heavy, slow, stable, the other faint, fast and highly responsive. Analysts at the time labelled it a fragment pair, possibly split from a single body decades earlier. But no clear parent object was ever identified. What stood out most was how quietly the blackout passed. No one saw what happened during the solar silence. When the larger object re-emerged, the smaller one was gone. The third case, logged quietly in the mid-2000s, involved another matched trajectory. This time, data from multiple satellites allowed for more detailed tracking, but once again, the crucial interval near the Sun remained opaque. The smaller object accelerated into blackout. The larger followed, and only the larger returned. Each of these incidents, on their own, could be explained away. Breakups happen. Small bodies don't always survive perihelion. Observational gaps are common, but the pattern is persistent. One large, one small, one stable, one nimble, a synchronized arrival at the Sun's doorstep, a silence, and then one of them disappears. The reason no one outside of specialized circles knows these stories is simple. None of the previous cases involved an object as massive or closely watched as 3I Atlas. Those earlier events were recorded as technical curiosities, not strategic anomalies, but 3I Atlas has changed everything. Its trajectory has been under global scrutiny for months. Every deviation is logged, modelled and debated. And now, with the second object locked to its timeline, what was once background noise has become the centre of the narrative. What makes this echo even more troubling is how clean the synchronization is this time. In past events, the smaller objects drifted into phase naturally. Their alignment imperfect, their timelines offset. This time, the match is precise. The second object's acceleration curve wasn't coincidental. It aligned itself over time, slotting into the same corridor 3I Atlas is carving out. That degree of timing would be rare for natural objects, extremely rare. Some researchers quietly refer to this pattern as the shadow effect, a faint, fast follower entering perihelion shortly before or after a primary body. It's a term used more in informal exchanges than in papers. No one has ever proven why it happens. Some argue it's simply the result of ancient breakups, fragments riding the same orbital highways as their parent bodies. Others aren't convinced. The light curves of the smaller companions have never matched standard cometary signatures. Their acceleration patterns are too clean, their mass signatures inconsistent. This brings us to the unspoken theory, the one circulating quietly, not in journals, but in late-night calls between analysts. The idea that these shadows might not be debris at all, that they might be probes, escorts or markers, objects synchronized deliberately with larger bodies, arriving in coordinated pairs. It's a theory that sits on the edge of science and speculation, where orbital data brushes up against the unknown. No agency has endorsed this idea publicly, but the pattern's persistence is forcing the conversation further than most would like to admit. The other element no one can ignore is what happens during blackout. Every recorded twin window event shares the same core characteristic: the silence hides the break. The smaller object either disappears entirely or re-emerges altered. Its velocity profile, brightness, or trajectory changes in ways that can't be fully explained by simple thermal stress or solar radiation. If the same pattern holds this time, the second object may not come back the same way it went in, or at all. This possibility is driving a level of behind-the-scenes preparation rarely seen for an inbound object. Coronagraph arrays are being calibrated to their limits. Independent networks are coordinating to pool their data, hoping to stitch together a more continuous picture of the blackout period. But even with this preparation, the truth remains: there will be blind spots. There always are. The echo of the past 3 events isn't just statistical, it's strategic. Each event followed the same rhythm: detection, acceleration, convergence, silence, and then something missing. This time the echo is louder, clearer, and harder to ignore, and for the first time the world isn't watching in hindsight, it's watching in real time. In quiet rooms far from public feeds, a growing number of orbital analysts have begun to call the second object something they avoided saying out loud for weeks: a probe, not a proven probe, not an officially classified or confirmed probe, but an object whose behaviour fits the kind of pacing, precision and coordination that natural celestial bodies rarely demonstrate. No agency has made a formal statement, and perhaps none ever will, but the language inside internal communications has changed. Words like fragment and companion have been quietly replaced with escort, leading body, and instrument. What pushed this shift wasn't just the acceleration spike or the synchronized perihelion, it was the clean precision of the orbit correction observed over the past few tracking intervals. Natural objects, even the most stable, wobble, they tumble. Their trajectories are chaotic under the influence of solar wind, radiation pressure, and microgravitational perturbations. But this second object isn't just holding its line, it's refining it. The timing adjustments are subtle, almost surgical. In the last 10 days, its arrival estimate for perihelion has narrowed from a 3-day uncertainty window down to less than 20 hours. That kind of tightening usually requires propulsion or controlled mass distribution, something that behaves like guidance. And it's doing this without a visible coma, without the erratic jetting you'd expect from an active comet. The working theory inside several observatory circles is that if this object is artificial, or even partially engineered, it may not need active propulsion at all. A structure shaped to exploit solar radiation pressure, or equipped with internal stabilizers invisible at current resolution, would be capable of fine steering. It would only need to ride the gravity well and make minimal adjustments to maintain its course. Another factor deepening suspicion is its positional relationship to 3I Atlas. If this were a fragment from the same body, the distance between the two should either gradually expand or contract in predictable ways under solar influence. Instead, the distance has remained unnaturally stable. It's neither drifting apart nor collapsing inward. It's locked, as if the second object is intentionally maintaining a trailing station relative to 3I Atlas. That kind of station keeping is almost unheard of in unbound celestial mechanics. If this were debris, it would have been pushed out of phase long ago, but the gap between them has held a silent formation, two objects moving toward the sun in something closer to formation flight than coincidence. It's worth noting that not everyone agrees. There are still conservative voices, veteran comet analysts and orbital modelers, who warn against the temptation to assign intention to what could still be an extreme outlier. Their view is that we've only begun to observe the second object recently. Late detection introduces large uncertainties. It's possible that what looks like precision is just the tail end of a natural evolution we missed, a slingshot of ice and dust perfectly timed by the physics of orbital mechanics, not by design. But others point to the historical echoes, the previous 3 twin window events. In each, the smaller object behaved like a follower, not a leader. It matched timing, trailed closely, and vanished during blackout. When that pattern repeats across multiple decades, the line between natural anomaly and orchestrated structure grows thin. This is why some are now calling the second object the shadow probe, not in any official capacity, but as shorthand for how it behaves. A follower that does not drift, a mass that moves like it knows where it's going, a body that mirrors the inbound trajectory of a larger, heavier primary object with unnatural fidelity. And if it is behaving like a probe, the next question is what it's probing for. Some of the more grounded analysts propose a simple explanation. If 3I Atlas is an unusually dense, stable interstellar object, then the second object might be a natural hitchhiker, a fragment caught in its gravitational envelope or moving in resonance with it. If this is true, it could offer scientists a rare glimpse into how interstellar bodies carry companions or debris across light years, but there's a more speculative layer that can't be ignored anymore. If these shadows appear repeatedly across time, always tied to large inbound bodies, always arriving in synchronized windows, then perhaps they're not hitchhikers at all. Perhaps they're instruments, markers that arrive first or alongside, recording, signaling, or observing. If 3I Atlas is natural, the shadow might not be. There's also the matter of radio wave silence. During inbound tracking, no unusual emissions have been publicly recorded from either object, but several low-frequency monitoring arrays are reportedly on alert for background noise anomalies as they approach perihelion. Not transmissions, but echoes, reflections, patterns that could indicate structured surfaces or engineered responses to solar radiation. If the second object is a probe, the blackout zone would be the perfect cover to reveal it. Historical precedent, quiet though it is, reinforces this. In 2 of the past twin window cases, localized signal interference was noted during the blackout period. It was faint, dismissed at the time as solar interference. But those cases are being revisited now with modern analysis. What was once shrugged off as noise is being re-examined as potential signature. For many, the most unsettling part isn't what the second object is, but how it's behaving relative to 3i Atlas. It's not wandering, it's not tumbling out of formation, it's pacing. And it's pacing toward a point of complete invisibility, just as its predecessors did. This is why, behind closed doors, the tone has shifted. There's no panic, just quiet, analytical urgency. The kind of urgency that comes when something has moved from anomaly to pattern, and from pattern to possibility. The probe hypothesis may not be proven. It may never be. But if the blackout plays out as it has before, we may not need words to understand its weight. A silent follower, a synchronized perihelion, a gap in time where eyes cannot reach. Late October is no longer just a date on the calendar. It's a collision of forces waiting to happen around the Sun. The perihelion corridor of 3i Atlas isn't just a stretch of orbital math. It's a volatile zone where the star's magnetic field, radiation pressure, and coronal plasma reach their most extreme. Any object entering that space doesn't just follow its predicted path, it's tested, stripped, and reshaped by forces that leave nothing untouched. That alone is enough to turn the perihelion pass of a single object into a high-stakes observation. But now there are 2, and they're arriving almost together. When 2 bodies converge on a similar perihelion point within hours of each other, their behavior is no longer isolated. Their environments overlap. This overlap matters. Around the Sun, objects interact not just with solar wind, but with the electromagnetic field lines that shape their trajectories in subtle, often unpredictable ways. When 2 distinct plasma envelopes intersect, one from a massive dense body like 3i Atlas, and one from a lighter, fast-moving companion, a new layer of complexity emerges. Solar physicists tracking the situation are quietly concerned. In their models, the incoming window between October 27th and October 31st is unstable. The Sun is entering a period of heightened activity. Coronal mass ejections have already spiked twice this month. These are vast eruptions of charged particles and magnetic fields that can engulf anything passing close. If a flare or CME coincides with the perihelion of 3i Atlas and the shadow object, the 2 bodies will be caught inside a storm that no telescope on Earth will witness directly. This is the crossfire, not an impact between the objects themselves, but between their paths and the living, unstable surface of the Sun. Solar coronagraph data already shows an increase in magnetic field tension near the coordinates where both objects are expected to pass. These are invisible lines of force that shape solar wind like ripples around rocks in a river. A single large body passing through can trigger turbulence. 2 synchronized objects can amplify it. This raises an uncomfortable scenario that's being modelled quietly but intensely: plasma interaction between the 2 bodies. If both develop tails or comas, even briefly, their charged particle streams could interact. That interaction wouldn't be visible from Earth during blackout, but it could leave fingerprints in the solar environment, distortions in plasma flow, irregular bursts of light, faint radio echoes. If the second object is lighter and more sensitive, it may be the first to respond to these forces. It could be thrown off course, accelerated unexpectedly, or destabilized entirely. It's the perfect storm for something to happen unseen. This is why, over the past week, several space weather observatories have been quietly retasking instruments to cover the perihelion corridor at higher temporal resolution. They're not just tracking 3i Atlas anymore, they're watching for interference patterns, the kind of subtle fluctuations that can reveal interactions between objects hidden behind the Sun. Even small variations in solar wind flow can tell a story if read carefully. And then there's the worst-case scenario, not in the apocalyptic sense, but in the observational one. If both objects encounter an active flare at the same time, tracking could be lost entirely. Signals from coronagraphs could be drowned out by noise, low-frequency monitoring could be disrupted. For hours, possibly days, there could be zero data from the perihelion corridor. A complete observational blackout in the very moment the anomaly reaches its peak. It's happened before. In past twin window events, one of the two objects vanished entirely during flare activity. The disappearance was written off as breakup and vaporization, but those events happened during low public awareness, when data was sparse and uncoordinated. This time, the world will be watching, or rather waiting, as the blackout consumes the sky. There's another factor often overlooked: gravitational wake effects. When two bodies move through a strong gravitational field at close proximity, their wakes can overlap, creating zones of altered velocity and turbulence. Even if the two objects never touch, they can disturb each other's flight paths indirectly. For 3I Atlas, this effect is minor. Its mass and stability give it momentum, but for the shadow object, this wake could mean the difference between a stable passage and a complete trajectory shift. This is where the theories begin to split. Some expect a natural interaction, turbulence, possibly fragmentation, maybe the disappearance of the shadow object. Others suspect something more calculated. If the second object is what some believe, a trailing instrument, the perihelion pass could be the point where it activates or performs a maneuver, shielded completely by the sun's glare. It's the one place in the solar system where an event can occur without instant detection. Radio arrays on Earth are already preparing for the silence. Several of them will remain locked on perihelion coordinates throughout the blackout, listening for unusual signatures. Not language, not signals, just anything that deviates from baseline solar noise. Any structured echo would be enough to turn suspicion into something sharper. Meanwhile, agencies remain quiet. Official bulletins speak only of anomalous but non-threatening inbound trajectories. No mention of coordination, no mention of the pattern. But among those studying the data, no one is treating this like a routine event anymore. In a few days, two objects will dive into the heart of the sun's most chaotic domain. No one will see what happens inside. We will only see what comes out the other side, or what doesn't. For those who've been tracking this story from the beginning, this is the point where everything converges: trajectory, timing, acceleration, mass, and silence. And somewhere in that crossfire, something will either change or end. The world isn't being told much about the second object. Publicly, the narrative remains focused on 3I Atlas, its size, its trajectory, and the countdown to perihelion. But behind that, a different kind of operation is unfolding. A network of observatories, agencies, and monitoring systems is exchanging data at a pace that doesn't match the public bulletins. This isn't the absence of information, it's the management of it. When high-interest objects approach the Sun, most orbital bulletins become automated, predictable, and transparent. Each update adds layers of certainty. But something changed in the last 2 weeks. Updates on the second object's acceleration profile, previously trickling through technical registries, have slowed to a crawl. Certain telemetry streams that would normally be available have gone dark, and the cadence of public orbital solutions, which normally increases as perihelion nears, has not followed that pattern. What emerges instead is a vacuum, a controlled quiet, and inside that quiet, signals are exchanged in smaller, more restricted channels. Several independent tracking groups have noticed a sharp increase in delayed postings and withheld parameters, particularly those related to the second object's light curve, mass model, and positional uncertainty. That kind of withholding doesn't happen by accident. It usually signals either national security involvement, commercial data lockdown, or pre-coordinated strategic silence. And this particular blackout isn't confined to one country, it's global. This raises an uncomfortable truth about how near-Sun anomalies are handled. When an event crosses the boundary between pure astronomy and potential strategic significance, information becomes currency. Agencies share what they choose, not what they know. And 3I Atlas, paired with a synchronized shadow object, has crossed that line. What's also telling is how quickly the language in official statements flattened out. In the early months of tracking 3I Atlas, updates were lively, full of technical nuance. Orbital uncertainties, reflectivity bands, mass models, everything was laid out plainly. But as the shadow object entered the picture, statements became short, vague, stripped of texture. The orbit was stable, The object was non-threatening, and its presence was expected. Those words mean very little in orbital mechanics, but they mean a lot in messaging. The pattern of silence mirrors past twin window events, though this time the scale is larger. In previous cases, the secondary objects vanished during perihelion without public explanation. This time, the anomaly is too visible to fully ignore, and so instead of explanation, there's a quiet, strategic delay. Inside private monitoring networks, chatter has shifted to the silence directive, an informal term used by independent trackers to describe the way information begins to constrict when something is being closely managed. No one is calling this an operation, but the fingerprints of coordination are clear. Simultaneous withholding of data across multiple registries, synchronized delay in official updates, and sudden limits on light curve access from major solar observatories. The radio silence adds another layer. Several monitoring stations accustomed to posting their readings publicly have temporarily gone offline, citing instrument maintenance or scheduled upgrades. That timing isn't random. These maintenance periods line up precisely with the projected blackout window of 3i Atlas and its shadow. To the outside world, it looks like a technical blip. To those watching closely, it looks like timed containment. Why the silence matters is not just about what it hides, but about when it happens. As perihelion nears, this is the window when small deviations in trajectory become critical. If either object shifts course, fragments, or alters its behaviour, those changes would normally appear almost instantly in public telemetry. That isn't happening now. If anything changes during this final approach, the world might not know until long after the fact. This strategy is not without precedent. In the early 2000s, when a twin arrival occurred under far less scrutiny, telemetry streams were throttled. By the time full data was released, one of the two objects was gone. The disappearance was explained away as fragmentation. But no contemporaneous tracking data existed. The gap made verification impossible. That silence became the explanation, and that may happen again. Strategic silence is not just the absence of sound. It's the creation of space for events to unfold unseen, unverified, and unchallenged. If something extraordinary occurs during the perihelion window, whether natural or not, the blackout of both observation and communication will define how the story is told afterward, and whoever controls the data controls the story. Observers know this, analysts know this, and it's why the shadow object's presence feels different. It isn't just a trajectory anomaly anymore, it's a narrative gap waiting to be filled. In a few days, two synchronized objects will vanish behind the sun. What emerges from that blackout may be something easily explained, or something harder to fit into the language of orbital bulletins, but either way, the silence will come first, and when it does, it won't just hide the event, it will shape its meaning. The closer 3i Atlas and the second object approach perihelion, the more attention shifts away from their visible paths and toward their spectral fingerprints. Light reveals what words do not. Even when the sun blinds everything, even when the optical signal vanishes, a body's material composition speaks through the way it interacts with radiation. That's why the newest wave of data isn't about positions or brightness. It's about what's hidden beneath the glare. Over the past 10 days, spectral readings of the second object have shown something no one expected. A flat reflectance curve where natural materials usually peak. Most comets, asteroids, and interstellar fragments have complex spectral patterns, the signatures of dust, ice, volatile compounds. But this object reflects in a way that's eerily uniform. Its surface, whatever it's made of, isn't acting like rock or ice. It's acting like something smooth, structured, and resistant to breakdown. 3i Atlas, by contrast, has a dense and noisy spectrum. It's massive, irregular, and chemically rich. Its readings suggest a body that is heavy, structured, and layered, something more akin to a dense metallic asteroid, or even a composite of exotic material. But the shadow object has remained coldly consistent. No flares, no variation, as if its surface doesn't care how close it gets to the sun. That's what makes analysts uneasy. Natural bodies change as they approach perihelion. Ice boils off, dust scatters, reflectance curves spike and warp, but the shadow's spectral lines have held almost perfectly steady, even as its velocity increased. Some scientists describe this behaviour as surface hardening. Others don't even try to name it. Here's why this matters. Spectral uniformity of this kind isn't just rare, it's strategic. A body that doesn't shed material as it heats up is harder to study. It gives away less, and if it maintains that stability through perihelion, it will move through the silent zone like a ghost, leaving little to no visible trace behind. But even the most controlled objects can't pass through perihelion without leaving some kind of imprint on the environment. And that's where things get even more interesting. Several chronograph teams have picked up early scatter patterns along the corridor the two objects are approaching. This scatter isn't tied to solar activity. It's localized, faint, and structured. Not a natural flare, not a random burst, a static ring of dust and plasma disturbances centered near the projected convergence point. If 3I Atlas is producing that pattern, it means its mass is interacting with the solar wind in an unusually structured way. But some analysts quietly suspect the shadow object. Its light signature is too clean. If it's reflecting like a shell, it may also be disturbing its environment differently from a normal comet, creating a signal without showing itself. This kind of hidden signature is what radio and plasma arrays are preparing for during blackout. They won't be able to see the objects directly, but they can listen. Even a faint interference pattern, even a short-lived electromagnetic echo, can betray structure where the eye can't. Historical twin window cases support this expectation. In the early 2000s, when one of the shadow objects disappeared during blackout, coronagraph data recovered later revealed faint geometric plasma distortions near perihelion. At the time, it was explained away as turbulence, but the shape of the distortion didn't fit turbulence. It fit structure. There's another layer that complicates everything: radio quietness. If the shadow object were fully natural, some level of signal scatter would have appeared already. Tiny, random bursts in background noise, just enough to be picked up by sensitive arrays. But that hasn't happened. The noise floor around its coordinates has remained clean, too clean. Some analysts describe it as a hole in the noise, a gap where there should have been chaos. This kind of silence can mean two things. Either the object is extraordinarily inert, a body so dense and stable it doesn't interact with the environment at all, or it's engineered to minimize that interaction, slipping through the solar wind like a blade through water. It's this duality of the signature, visible but not loud, reflective but not chaotic, that has fueled quiet speculation that the second object isn't just shadowing 3I Atlas. It may be scanning, signaling, or listening in some way we can't yet detect. Official channels continue to say little. The few public briefings mention only low albedo variants, an unusual but stable spectral behavior. Those are polite ways of saying, it doesn't act like anything we've seen before. For agencies that deal in orbital data, this isn't just an anomaly, it's an information problem. How do you explain to the public that something is there, that it's moving toward the sun, that it doesn't behave like rock or ice, and that no one really knows what it's made of? Silence is easier, but silence can only hold so long. Once the blackout begins, the only clues we'll have to what happens near perihelion may be these subtle fingerprints in the solar wind. Distortions, echoes, absences where noise should have been, and if history holds, if the echo pattern repeats what's been seen before, the shadow object may not reappear at all, but its signature might, and that signature could be the only thing left to tell us what crossed the sun alongside 3I Atlas. Perihelion doesn't happen all at once. It's not a single moment on the calendar. It's a process, a sequence of critical hours when an inbound object slips from visible space into the solar glare, and with it, the rest of the world loses the ability to watch. For 3I Atlas, this maneuver window begins just before midnight UTC on October 28th and locks into full blackout on the 29th. The second object, moving slightly faster, is projected to cross that observational edge roughly 10 hours earlier. That 10-hour offset has now become the most closely studied timeline in the entire event. Every interstellar object approaching the sun goes through this corridor, but this time, two of them will be inside the same observational funnel at once. One heavy, stable, and slow, the other small, sharp, and precise. What makes this moment so critical is the relative spacing between the two. If the shadow object is more maneuverable, or built to respond to solar conditions in real time, this is the window where it can alter its position without anyone seeing. It doesn't need to accelerate wildly or light up the sky. It only needs to shift a few degrees in the right place to disappear in a way that no coronagraph can untangle. That possibility isn't theoretical. In past twin window events, shadow objects didn't vanish at perihelion itself. They vanished before it in this exact maneuver corridor. Their signals drifted out of lock, their projected positions slipped off target, and by the time instruments recalibrated, the blackout had already begun. When solar glare returned to tolerable levels days later, the primary objects re-emerged. The shadows did not. It's this history that makes this window so sensitive. The shadow object has held a stable trailing position behind 3i Atlas for weeks. Its orbital arc isn't drifting outward, it's pacing tightly. And this is the first and last chance it has to break away unseen. Some analysts are modelling a low-angle lateral slip, a manoeuvre so small it would be undetectable with ground-based instruments. Others propose something even simpler, a controlled deceleration. If the shadow object is lighter and uses solar pressure for guidance, it could simply slow its inward velocity slightly, letting 3i Atlas surge ahead into perihelion while it drifts into a quieter, more concealed corridor. Either path would break the trailing formation without creating a visible flare. And here's the unsettling part. This kind of movement fits with the historical pattern. Every time a shadow object disappeared in the past, the gap between its last confirmed sighting and perihelion was under 12 hours. A clean maneuver window, a silence no telescope could pierce. The blackout makes this the perfect cover. Even space-based solar observatories like those aboard major monitoring missions can't offer full coverage in those final hours. Solar interference spikes, positional errors multiply, and signal-to-noise ratios collapse. If anything shifts, the world will only discover it afterward, when it's too late to know where it went. Inside certain tracking rooms, there's a phrase quietly circulating, the corridor event. It's not an official term, it's shorthand for the possibility that the shadow object isn't meant to survive perihelion the way 3i Atlas will. It may not be destroyed at all, just gone, either manoeuvred, shielded, or erased into a trajectory no one can follow. This is also the point at which radio silence becomes most dangerous. If the shadow object is designed to minimize its environmental footprint, as spectral data suggests, then the maneuver window could unfold without a single detectable ripple. A shift this clean would mean no visual evidence, no radio echo, and no observable wake, just disappearance. And if it's not natural, if this object is something more deliberate, this is the moment it was built for. A single window of guaranteed invisibility before the entire solar system blinks. Publicly, nothing is being said about this timeline. Orbital bulletins keep their language simple: expected blackout interval, standard perihelion loss, normal signal degradation. But private simulations tell a different story. The maneuver window is the most volatile point of the entire approach, more so than perihelion itself. For the analysts watching from behind the curtain, this isn't a countdown to impact. It's a countdown to uncertainty, a vanishing point carved into a clock. By the time the sun takes the sky and everything turns to static, whatever happens in that corridor will already be over. All that will remain are trajectories, either one re-emerging or none. The moment the two objects enter the solar silence zone, optical observation becomes useless. But light isn't the only way to track an anomaly. Buried beneath the glare, hidden in frequencies that most telescopes ignore, are the electromagnetic fingerprints of anything crossing that corridor. For weeks, a quiet race has been building between agencies, private observatories, and independent monitoring networks, not to see the perihelion, but to hear it. Solar blackout doesn't silence everything, it just blinds us to the visible. Radio waves, low-frequency electromagnetic noise, and plasma scattering can still leak through the chaos. When an object passes close to the sun, its structure, whatever it's made of, interacts with that environment, bending, reflecting, and sometimes amplifying those signals in measurable ways. Those effects are small, fragile, and easily lost. But they're not random, they're signatures. This is why, over the last 72 hours, several monitoring stations around the world have quietly recalibrated their arrays. They're no longer trying to resolve an image of the shadow object, they're trying to catch its echo, the faintest distortion that might betray its presence when everything else is blind. The key frequency band is a narrow slice of the low-frequency spectrum, well below the noise of normal solar storms. If the shadow object has any structured surface, any kind of dense, smooth geometry, it will leave a layered echo in that band, a signal that looks nothing like random plasma hiss. That signal might last seconds, maybe minutes. For 3i Atlas, it's expected to produce a strong, chaotic burst as it punches through perihelion. But for the shadow object, the prediction is different. If it maintains its spectral uniformity, it will cut through like a blade, leaving a clean, unnaturally sharp signature. This is what some analysts are calling the signal layer, the invisible strata of evidence that only exists when the world isn't watching. A momentary spike, a ripple buried beneath the roar of the sun. If nothing happens, it will pass unnoticed, lost in static. But if the shadow object is more than rock and dust, this layer could be the only proof we ever get. Historical patterns give weight to this expectation. In at least 2 previous twin window events, faint structured radio signatures were detected during blackout, recorded as anomalies and dismissed as interference. But in retrospect, those signatures appeared in the exact time frame when the shadow objects disappeared. They weren't long, they weren't loud, but they were precise, clean spikes that didn't match the solar background. This time, the technology is sharper. Ground-based low-frequency arrays are linked in real time across continents. A network of space-based coronagraph monitors is set to record at sub-second intervals. For the first time in these recurring events, the signal layer will be mapped deliberately, not discovered after the fact. What makes this layer so delicate is the timing. The shadow object will likely enter the blackout hours ahead of 3i Atlas, meaning its signal, if any exists, will appear first. It may be faint, isolated and gone before the primary object even reaches the perihelion corridor. If it does, it won't be accompanied by light, flares, or public announcements. It'll exist as a line on a radio spectrogram, hidden in data archives, waiting to be interpreted after everything is already over. That's what makes it so dangerous to ignore. Signal layers like this are the closest thing to a forensic trail in blackout events. They don't show shape or form, but they reveal behavior. A clean spike could indicate structure, perhaps a reflective shell or engineered geometry. A fragmented burst might suggest instability, breakup, or rapid acceleration. And silence, true, perfect silence, could mean either total absorption or a maneuver so precise that nothing was left behind. The shadow object's spectral uniformity adds a strange weight to this moment. Most natural objects leave messy signals, this one may not. And that's why, in monitoring rooms around the world, the upcoming blackout isn't being described as a moment of observation loss. It's being described as the listening window. Some teams have even gone further. They've set up autonomous detectors to watch for patterns that humans might miss. If something structured passes through the solar storm, something that doesn't behave like a natural body, an AI system will flag it in real time. But whether anyone outside those rooms will hear about it immediately is another question entirely. Agencies know this. Strategic silence isn't just about withholding visuals, it's about controlling when the signal is acknowledged, or whether it's acknowledged at all. For the public, late October may pass with no event at all. No flare, no flash, no image. Just a story that disappears into the sun, but deep inside the noise, the truth may already be written in a few seconds of radio data. And if the shadow object does what so many before it did, vanish cleanly, leaving only an electromagnetic scar, then the signal layer may be all we have left, a signature without a witness. In orbital mechanics, synchronization isn't supposed to be neat. Space is messy, trajectories drift, accelerations fluctuate, and no 2 inbound objects ever behave like mirror images of one another. That's why the story of 3i Atlas and the shadow object has unsettled so many people who've spent their careers in this field. It's not just the timing, it's the precision of their dance. The coordination theory isn't official. It doesn't appear in press briefings or academic abstracts. It exists in the quiet corners of data networks, among analysts, deep space trackers, and plasma physicists who have seen just enough to know when something doesn't add up. The theory begins with a simple observation. 2 bodies have no reason to maintain this level of orbital synchronization unless something is binding them, gravitationally, mechanically, or deliberately. The first pillar of the theory is trajectory locking. For weeks, the shadow object has maintained a constant trailing distance behind 3i Atlas, neither drifting outward nor collapsing inward. Natural fragments can remain near their parent objects for a while, but not like this. Minor differences in mass, shape, and solar radiation pressure should have caused visible divergence. Instead, the spacing has held clean and narrow, as if the shadow is responding in real time to the movements of the larger object. The second pillar is temporal alignment. Both objects are now projected to pass through perihelion in near-perfect sequence. The probability of this happening randomly is low, not zero, but low enough that most seasoned trackers dismiss it as unlikely without some common origin or coordination. If the shadow is truly independent, the chance of it threading the same solar corridor with such precision is vanishingly small. The third pillar is behavioral asymmetry. 3i Atlas is massive, dense, and stable. It acts like something with tremendous inertia, moving through space with the indifference of a large body falling toward a star. The shadow is the opposite: light, precise, responsive. Their relationship mirrors what you'd expect between a carrier and a trailing instrument, or a beacon and its receiver. In many ways, it behaves less like a partner and more like a companion system, echoing the larger object's path rather than simply sharing it. These three pillars don't prove anything by themselves, but when viewed together, they create a shape in the data that is difficult to ignore. Coordination theory argues that the shadow object is either physically related to 3i Atlas or deliberately synchronizing with it. Two main scenarios dominate the debate. The first is the fragment scenario, that the shadow object was once part of 3i Atlas, a mass ejected in deep space long before entering the solar system. In this scenario, the two bodies share a common origin, and their synchronized perihelion is the result of that shared past. This theory explains their orbital similarity, but struggles to account for the shadow's clean, stable acceleration and its unchanging spectral signature. Fragments don't behave like precision instruments. The second is the escort scenario. In this model, the shadow isn't just travelling alongside 3i Atlas, it's reacting to it. Perhaps it was released intentionally somewhere along the inbound arc, or perhaps it was always positioned this way, its purpose tied to whatever 3i Atlas represents. It's not the larger object's twin, it's its observer, scout, or signal carrier. This idea sounds speculative because it is. But what makes it harder to dismiss is how closely it matches the patterns of previous twin window events. In every historical case, the shadow object displayed similar behaviour: light, fast, responsive, vanishing into blackout just before or just after the primary body, never at the same time, always in sequence. The timing is almost too consistent to be meaningless. If this pattern were a coin toss, it wouldn't have landed on the same side this many times. There's also a more subtle piece of the puzzle: solar trajectory harmonics. If an object wanted to mask its movement, to hide inside the natural noise of the sun's environment, there's no better way to do it than to synchronize with something bigger. The larger body becomes the anchor, drawing all attention, dominating every instrument. The shadow becomes the whisper behind the roar, slipping into the same corridor unnoticed. Coordination theory suggests that this isn't accidental, it's design. Some analysts point to how agencies have handled this event, not with confusion, but with containment. Strategic silence, delayed data releases, and tightened orbital bulletins are often more revealing than the anomaly itself. It implies that what's being seen isn't a total unknown, but something that fits a pattern someone has already prepared for. This also connects directly to the signal layer. If the shadow object is deliberately synchronized, perihelion isn't just a shared moment of heat and gravity, it's an opportunity. In the noise of solar plasma, one body could transmit, maneuver, or even fragment without drawing direct attention. If the timing is perfect, 3i Atlas becomes both cover and distraction. The most cautious observers stop here, calling it a rare orbital coincidence, but a growing number quietly accept what coordination theory implies, that this may not be two random travellers crossing paths. This may be a system moving together, one visible, one quiet, both vanishing into the sun's shadow exactly as they've done before. In the hours before blackout, every telescope will still be aimed at 3i Atlas, but every array, every radio ear, every plasma monitor will be waiting for the shadow, the quiet half of the pair. If coordination theory is right, that's where the real story will unfold. And if the pattern holds, it may unfold without anyone watching. The final hours before perihelion are unlike anything else in orbital tracking. The precision of math begins to give way to the unpredictable forces of the star itself. Radiation pressure climbs, solar wind thickens, coronal mass ejections, invisible until they're too late to counter, can warp or shatter trajectories in a heartbeat. For most inbound objects, perihelion is a test of survival. For these two, it's something more. It's the centre of a story that's been building for months. 3i Atlas is expected to cross its perihelion point on October 29th, its path bending just enough to skim the Sun's outer atmosphere before swinging back out. The shadow object's trajectory runs ahead of it by hours, tight, silent, and deliberate. When the two finally disappear behind the glare, one thing will define everything that follows. What happens inside that corridor can't be observed directly. It can only be inferred from what comes out on the other side. Historically, these hours have marked the collapse of certainty. In the 3 previous twin window events, this exact moment is when the smaller shadow object either fractured, slipped, or disappeared entirely. No explosions were ever seen, no flash, no dramatic signal, just a clean break in telemetry, a silence so sharp it looked like the object had been erased. Days later, the larger body re-emerged. The shadow did not. The current models offer several possibilities. The first, and most conservative, is the fragmentation scenario. The shadow object, being lighter and more responsive to solar forces, may simply disintegrate under perihelion stress. If it's natural, a shard, a remnant, or a porous structure, the Sun will claim it in seconds. No one will see the flare. It'll be drowned out by the star's own brightness. The second possibility is the deflection scenario. As solar winds intensify, the shadow could peel away from the shared corridor, accelerating along a slightly altered trajectory, slipping out of alignment with 3i Atlas. If that happens, tracking it after blackout would be nearly impossible. A single degree of deviation here translates into millions of kilometers weeks later. It could vanish into the dark. But there's also a third scenario, the one that aligns most closely with coordination theory and the repeating historical pattern, the maneuver or transfer scenario. In this version, the shadow object uses the Sun itself as a cover, making its decisive move inside the blackout, shielded from observation by the very environment designed to hide it. It could decelerate, shift orbit, or even fall deeper into the star's influence. If the shadow isn't natural, this is the moment it was built for. Right now, a network of space-based coronagraphs is preparing for this exact sequence. They won't see shapes or surfaces, but they will catch environmental echoes, waves in plasma, bursts in radio, disruptions in solar wind. For analysts, those will be the only breadcrumbs left in the dark. If anything shifts, it won't be a spectacle. It will be a quiet, technical ripple, detected hours after it's already happened. That's what makes this moment so unsettling. Perihelion isn't just a point in space. It's a blind crossing, a knife edge between known and unknown. For weeks, everything has pointed here. The acceleration spike, the synchronized trajectories, the mass discrepancy, the blackout window, the signal layer. All of it converges into a span of hours where both objects will fall into the star's blinding light, and we will not be able to follow. The timing is surgical. The shadow crosses first, slipping under the radar while the world still has its eyes on 3i Atlas. Then, as the larger object follows, the shadow is already gone, either ahead of it or nowhere at all. This offset, so small yet so deliberate, mirrors the timing of every shadow disappearance in the past 3 decades. It isn't dramatic, it's quiet, precise. Like a clock striking a note only those listening closely will hear. No one outside the tracking networks will notice the exact moment perihelion happens. It won't look like a meteor or a flash in the sky. It won't appear in public feeds or live streams. It will happen behind the Sun, where no one can look. And when that moment passes, the world will be split in two. The time before perihelion, where everything is mapped and measured, and the time after, where everything depends on what emerges. For most natural objects, perihelion is the end of the story. For 3i Atlas, it may just be the beginning. The shadow has already set the tempo. 3i Atlas follows it now into the glare. 2 synchronized travelers, one overt and one silent, both stepping into the one place no one can see. The final tracking markers for both 3i Atlas and the shadow object were logged within hours of each other. After that, the data streams thinned, telescopes fell away from their targets, and the world went blind. The two objects have now entered what observers call the black sky interval, the period when nothing can be confirmed and the story unfolds beyond human sight. There's something profoundly unsettling about this stage. For weeks, analysts have been buried in models and telemetry, watching every fractional acceleration and orbital refinement. Now everything they've been preparing for is happening in real time, and no one can see it. The black sky isn't just an absence of light, it's a pause in knowing, a space between the last number and the next. In past twin window events, this interval always ended the same way. The larger object re-emerged days later, as expected. The shadow never did. Its absence was accepted without proof. No one could prove what happened in that corridor, because there was never any evidence to prove anything at all. Just silence and a line of orbital projections that suddenly stopped. This time, though, the silence feels heavier. Too many anomalies have stacked themselves atop this event. The perfect synchronization of their inbound arcs. The acceleration spike that followed no natural curve. The mass discrepancy that refused simple explanation. The uniform, engineered spectral signature. The deliberate alignment of their blackout window. And the faint but structured echoes forming in the signal layer. Each of these alone could be explained away. Together they draw a shape. Not a conclusion, but a pattern that keeps returning. Every time a shadow object appears, it follows the same rhythm. Follow, align, vanish. Never at random, never in chaos, always in silence. Right now, the official channels are quiet. Bulletins remain frozen on the last known positions. Solar activity alerts have replaced orbital updates. If something happened in the maneuver window, if the shadow object slipped, fractured, or moved intentionally, we won't know until the blackout ends. And if it followed the pattern, there may be nothing to find at all. For the people in the tracking rooms, this is the most difficult part. All the equations, all the telemetry, all the speculation. None of it matters now. The outcome is already written somewhere on the other side of the sun. The black sky is the hinge, and they're just waiting for it to turn. Even in this silence, a few instruments are still listening. Arrays tuned to frequencies buried beneath the solar storm are scanning for any final whisper in the noise. A narrow spike, a clean cut, a sudden absence of background hiss. That's all it would take to confirm that something moved deliberately in the dark, that something used the perihelion corridor not just to pass, but to disappear with intent. If nothing is found, history will repeat its old rhythm. 3i Atlas will reappear, the shadow won't, and the silence will be folded into the archives like all the other unexplained absences before it. But if a signature emerges, even faint, it could rewrite how we think about these events. A moment hidden in plain light, using the sun itself as a shield. There's a reason some analysts have begun calling this the quiet storm. Because unlike explosions or impacts, these events leave no spectacle, they leave questions. And those questions echo longer than any flare could burn. The world is now in the waiting phase. The sun holds both travellers, one known, one silent, in a corridor no one can see. Somewhere in that darkness something is happening. It may be ordinary, it may be extraordinary. But it will not be witnessed. When the blackout ends, either 3i Atlas will emerge alone as the past predicts, or this time, something will break the pattern. And if the shadow never reappears, if it fades like the others, the black sky will swallow another unanswered question. This is where the story rests for now, in silence, in absence, in the dark between what we know and what we never will. For months, everything has been building toward this moment. Two objects, one timeline, one corridor of light too bright to see through. Now both 3i Atlas and the shadow have crossed into the part of the sky where stories don't unfold in front of us. They unfold without us. The tracking systems are quiet, the instruments are waiting. And for the first time since this began, the night sky gives no answers. The blackout window is a blindfold that history has worn before. Every previous twin window event followed the same shape. Synchronized approach, sudden silence, partial return. The larger object re-emerges days later. The shadow never does. That pattern has defined the narrative for decades. But this time, the silence carries more weight. It isn't just two trajectories disappearing, it's the accumulation of everything that doesn't fit. A flawless acceleration curve, a mass that defies expectation, a reflectance signature too smooth to be natural, a blackout timed down to the hour. and the growing suspicion, whispered in observatories around the world, that none of this is accidental. Soon, 3i Atlas will either return to view, or it won't. If it does, it will carry the usual headlines: perihelion passed, trajectory stable, mission data archived. But beneath those calm statements will be the missing half of the story: the shadow's absence. Another silent vanishing tucked into a corner of solar space no one can touch. The radio arrays will go back to their routines, the bulletins will grow shorter, the data will settle into a neat official record, and for most of the world, the moment will end there. But those who have followed this from the beginning will know that something deeper happened in that thin sliver of time when the sun took both objects into its glare and gave nothing back. What's left is a blank space, a vanishing point that can be measured, timed, archived, but not explained. It will live in the data like the others before it, not erased, not solved, just waiting. And that's the quiet truth of this story. The most decisive moment didn't happen in the open. It happened where no one could watch, in the glare, in the silence, in the black sky. Whatever 3i Atlas is, whatever the shadow object was, their story has now crossed beyond the reach of light and into something we can only name when it decides to show itself again, if it ever does. The world is watching for a return, but the shadow may already be gone.